Welcome to today's deep dive. I am your host, and I want you to just close your eyes for a second and transport yourself.
Glad to be here and
David.
transport myself where exactly?
Imagine you're standing right in the dead center of a massive industrial construction site.
Yeah.
Maybe it's a new chemical plant or a refinery or some massive energy facility.
Oh, yeah. The kind of place where you have to wear a hard hat, safety glasses, steel-toed boots, and, probably a full fire-retardant suit just to walk through the front gate.
Exactly. And it is just this total assault on the senses. You've got pipes, thousands of them weaving everywhere like this giant bowl of chrome spaghetti.
Right.
There are massive steel beams swinging overhead on cranes. You've got miles of cabling snaking through these metal trays. It is loud, it's completely chaotic, and frankly, it just looks incredibly expensive.
It is expensive, extremely. But, looking at all that chaos, the question that always keeps me up at night isn't how do they build it, it's how do they actually pay for it?
Yes. And that is exactly what we are unpacking today. Because I've always wondered about that. Do you just, get one giant receipt at the end of the project? Does the builder just hand the client a bill that says, one factory, $1 billion, please pay by Tuesday?
Oh, man. If you did that, you would be in court for the next 20 years. The financial arguments would literally never end.
So to figure out how this actually works in the real world, we are doing a deep dive into the financial DNA of a mega project. We've got our hands on two very dense, very specific documents from a standard FIDIC Red Book construction contract.
Right, which is essentially the international Bible for construction contracts.
Yeah.
If you're building something huge in Europe, the Middle East, or Asia, you are very likely using FIDIC rules.
Exactly. So we have one document called Unit Rates for Construction Preambles, which basically acts as the rule book. And then we have the raw data, which is a unit rate schedule specifically for piping.
Yeah.
And our mission today is to decode how billions of dollars are managed through these tiny little line items.
And we aren't just looking at prices here, which is the fascinating part. We are looking at the definitions that prevent total chaos on a job site. Because, as we'll see, the price of a pipe isn't just the price of a pipe. It's actually a mechanism for transferring risk.
Okay, let's unpack this. Because the first thing that really jumped out at me in these preambles is this concept of the measured work composite rate.
Yes, that is the core philosophy of the whole system.
In the general preambles, specifically clause 1.5, it talks about this rate, and it uses this phrase over and over again, fully inclusive.
That phrase, fully inclusive, is probably the most dangerous phrase in the entire contract if you are a contractor.
Really? Why is that? Because it sounds pretty standard to me. You pay for what you get.
Because fully inclusive means the rate you quote for a specific task, say, installing a steel beam must cover absolutely everything required to make that happen, except the steel itself, if the client is providing it.
The document actually lists these out explicitly. It says the rate isn't just the cost of a brick or a pipe. It covers, and I'm quoting here overhead, profit, small tools, supervision, insurance, taxes, and even cleaning and clearing up.
Right, so think about that practically. You are a contractor.
Yeah.
You look at the spreadsheet, you see a line item that says, install steel beam. And let's say you quote $100 for that. A novice looks at that and thinks, okay, the welder costs $50, so I make $50 profit.
But you're saying it pays for way more than just the welder.
It has to pay for the site office where the welder eats his lunch. It has to pay for the electricity running that office. It has to pay for the foreman shouting instructions. It has to pay for the guys sweeping up the metal shavings afterwards.
So if the contractor forgets to factor in the cost of the broom,
they are buying that broom out of their own pocket, and the preambles are ruthless about this. Clause 1.5b explicitly says the employer will not reimburse for lost overheads due to omitted scope.
wow, so it's basically a speak now or forever hold your peace situation.
Exactly. You build the risk into the rate. If you underestimate the cost of cleaning up or the cost of insurance or the cost of your own headquarters, you don't get to ask for more money later. The client has transferred that risk entirely to you right off the bat.
That makes total sense. Now, I want to look at the definitions of action because this is where the rubber really meets the road. The document defines three main stages: supply, fabricate, and erect.
And the distinctions between those three are critical.
Let's start with supply. Clause 1.2.a. It's not just buying the material. It includes wastage factors, inspection, packing, and even quarantine facilities.
That wastage factor is huge. Let's say you need to install 100 meters of pipe. You can't just buy exactly 100 meters.
Why not?
Because you're going to cut the ends off to bevel them. You might drop a piece and dent it. You might find a defect from the manufacturer, so you actually need to buy, say, 105 meters to get 100 meters of finished installed work.
But the client only pays for the 100 meters.
Correct. The client pays for the net installed amount, the cost of that extra 5 meters. You better have hidden that inside your supply rate. If you didn't, you are literally giving away pipe for free.
That is wild. Then we have fabricate. This includes shop drawings, cutting, and handling. And finally, erect or install. This one fascinated me. It includes trial fitting.
Oh, trial fitting is a massive hidden cost that catches people out.
What does that actually look like on a real site?
Well, imagine you have a massive piece of equipment or a complex spool of pipe that needs to fit into a really tight space 50 feet in the air. You don't just rig it up there and hope for the best.
Right, it'd look pretty silly if it got up there and didn't fit.
Exactly. So often, you will assemble the whole thing on the ground. First, you trial fit it just to make sure all the bolt holes align. Then, you take it all apart. Then you rig it up. Then you lift it. Then you build it again in the air.
And you only get paid for the final installation?
That is right. The rate for install has to cover that entire dance. The trial, the dismantling, and the final build. If you quoted the job thinking you just had to bolt it together once, you are going to lose your shirt on labor costs.
So the aha moment here for me is that when you see a price for, say, install valve, it effectively includes every single logistical headache required to get that valve from the delivery truck to the pipe, including the bolts, the gaskets, the testing, and the trial run.
Precisely. It simplifies the billing for the client tremendously, but it massively complicates the estimation for the contractor.
Now, to keep track of all these millions of parts, the documents lay out a system. Section 2 introduces the work breakdown structure, or WBS.
I always like to call this the Dewey Decimal System of Construction. Without it, you would just have a giant pile of metal and a lot of very confused people.
It's a 7-level coding system. Let's walk through it because it's actually quite elegant when you look at it.
It starts broad and gets incredibly specific. Level 0 is the asset or facility. Level 1 is the area. For example, code 02 is inside battery limit, which usually means the main processing area.
And then level 2 is the component, like a specific unit. Level 3 is the discipline. This is where we see codes like PA for piping, ST for structural, or RW for roadworks.
And then we really dive into the details. Level 4 is material. For piping, we see P01 is carbon steel. Level 5 is the activity, like supply and fabricate. Level 6 is the description, like the schedule or thickness. And finally, level 7 is the specific item size, like 12-inch diameter.
You end up with this long code string that looks like 02.1.pa.pa.0.1.0.1.0.014.
And to a project manager, that single string tells a complete story. It says, inside the main unit, this is a piping task, using carbon steel, specifically supplying pipes for shop fabrication, schedule 120 thickness, and it is 14 inches wide.
That granularity is mind-blowing to me. Why do they need to be that specific? Why not just have a simple code for pipe?
Because the cost and the effort are totally different. Welding a 14-inch pipe takes significantly longer than welding a 6-inch pipe. Welding carbon steel is entirely different than welding stainless steel. You need a specific bucket for every single dollar to land in. This allows the project manager to track every nut and bolt across a billion-dollar site.
Speaking of pipes, let's jump into the piping data document itself. This thing is so dense, it is just page after page of tables.
It represents the sheer volume of options on a site like this. We are seeing schedules, which is just the industry term for wall thickness, ranging from Schedule 5, which is quite thin,
all the way up to Schedule XXS.
double extra strong.
That sounds like a superhero name.
It practically is. These are pipes with incredibly thick walls designed to handle extreme pressure, sometimes thousands of PSI. If that kind of pipe bursts, it isn't a leak. It's an explosion.
Now, there is a very specific rule in the preambles about how you measure this pipe to get paid. Clause 3.1 says piping is measured along the center line through all fittings.
This is a classic point of contention in construction. Imagine a pipe going around a corner. The outside of the bend is physically longer than the inside of the bend. So if you are the guy selling the pipe, you obviously want to measure the outside curve. If you are buying it, you want to measure the inside.
So the contract acts as the referee here.
Exactly. It steps in and says, stop arguing. We are measuring imaginary line right down the center, and it says you measure through the fittings. So you run the measurement right through the middle of the elbows and the T's.
But not through the valves.
No, and that is a key distinction. Valves are enumerated, meaning they are counted one by one. You get paid, say, $500 to install the valve itself. But the pipe, you just run a tape measure down the center line and subtract the valve space.
I noticed a big distinction in the WBS codes between shop and field work.
Yes. Code 100 to 119 is usually shop fabrication. Code 120 and up is erection or field work.
Why separate them so strictly? A weld is a weld, isn't it?
Oh, definitely not. Shop work includes things like cutting, beveling the edges, and welding in a highly controlled environment. You have overhead cranes, you have machines to perfectly rotate the pipe for the welder. It is basically factory work, efficient and safe.
And field work.
Field work is out in the elements. It's raining, it's muddy, you might be 50 feet up on a scaffold, hanging upside down, trying to weld a joint in the wind. It is much harder, much slower, and therefore it is much more expensive. The rates have to reflect that reality.
There is also a mention of field run pipe in the codes.
Those are usually the small pipes, typically under 2 inches. You don't prefabricate those in a shop because they are too fiddly. You just hand the field crew a bundle of straight tubing, and they bend it on site to fit around obstacles, kind of like installing brake lines on a car.
There are some hidden costs buried in these piping rates that really surprise me. For example, testing.
Clause 3.1 meters. This is another massive risk transfer from the client to the contractor.
It says the rate for hydro testing, which is filling the pipe with water to check for leaks, is measured once.
That is the operative word, once.
So walk me through the nightmare scenario here.
Okay, so you are the contractor. You have had a crew working for weeks welding this massive, complex system. You bolt it all up, you fill it with thousands of gallons of clean water, you pressurize it to 1.5 times the operating pressure. Everyone is standing around watching.
And then pop.
Exactly. A tiny pinhole leak in a single weld. Water sprays out. The test officially fails.
What happens next?
You have to drain all that water. You have to grind out the bad weld. You have to re-weld it. You have to fill the entire system up again. And you have to pressure test it again.
And who pays for that second test?
You do. The contractor. The client pays for one successful test. The cost of all that rework, the water disposal, the delay to the master schedule, that is entirely on you.
That puts a massive premium on quality control.
It absolutely does. If your welders are having a bad day, you aren't just losing time, you are hemorrhaging money.
Another one that stood out to me was identification. Clause 3.1e.
Right. A pipe isn't finished until people know what is actually inside it. The rate includes painting color codes, applying flow arrows, and tagging.
So if you install the pipe perfectly, you weld it perfectly, you test it perfectly, but you forget to put the little sticker on it showing which way the water flows.
You haven't finished the item. You do not get paid. It is that strict.
Piping isn't the only discipline with these quirky rules either. I want to compare this to steel, mechanical, and civil works, because each one seems to have its own unique gotcha built into the preambles.
They really do. They all have their own flavor of risk. Let's look at structural steel in Clause 3.3.
It is measured in tons. Seems pretty straightforward to me. Weight is weight.
You would think so. But look closer at the wording. It is measured net as fixed. And it specifically says no allowance is made for rolling margin or the weight of the weld metal.
Rolling margin. What exactly is that?
When steel comes from the manufacturing mill, it has a tolerance. A steel beam might technically be listed in the catalog as 100 kilograms per meter, but maybe the steel rollers at the factory were a bit worn down that day, so the beam comes out slightly thicker. It might actually weigh 102 kilograms.
So the contractor buys the steel from the mill by actual weight.
They pay for 102 kilograms, but the client pays them based on the theoretical 100 kilograms. The contractor eats the difference.
And the weld metal. You're adding molten metal to join these huge beams together that adds actual weight to the structure.
You don't get paid for that either. It is deemed included in the rate per ton.
Let's move over to mechanical equipment. Clause 3.2. There was a specific note about reassembly.
This happens all the time with big machinery. Let's say you were installing a massive crane or a huge gas compressor. It is simply too big to ship on a highway truck in one piece. So the manufacturer takes it apart, they remove the handrails, the platforms, maybe they even split the main casing.
So it basically arrives on site like a giant IKEA kit.
Exactly. And when it arrives, the contractor has to put it all back together. The rate for install equipment automatically includes that reassembly. If you quoted a price thinking you just had to lift one big box off a truck and bolt it down, you are in for a rude awakening when you open a crate and see 1,000 loose parts.
And shims and grout are included in that too.
Yes. You never just bolt a heavy machine directly to uneven concrete. You have to level it perfectly using little metal plates called shims, and then you pour a special concrete called grout underneath to lock it all in place. The preamble says all of that labor and material is included in the one-line item.
Okay, let's talk about subworks. Clause 3.7, excavation.
The digging of holes.
Right. It is measured by net volume. But the rate must include upholding sides of excavation.
This is a huge safety issue and a massive cost issue. If you dig a deep hole, the dirt naturally wants to fall back in. It wants to collapse, so you have to shore it up. You put up wood or steel supports to keep the walls vertical so people can work down there safely.
And the preamble is saying that cost is already supposed to be in the rate.
Correct. So if you are digging in loose, sandy soil, you might actually spend more money on the shoring than on the actual digging itself. If you didn't check the soil report before you bid the unit rate, you are in serious trouble.
And what about demolition?
That includes disposal off-site. You can't just knock a brick wall down and leave a rubble pile for the client. You have to make the debris disappear entirely.
It just seems like every single discipline has these hidden tasks that are absolutely essential but not obvious in the line item name.
That is the whole nature of the composite rate. It forces the builder to think about the entire process from start to finish, not just the raw material.
Let's touch on the nervous system of the plant, electrical and instrumentation. Clause 3.6.
This is where things get really, really granular.
Cables are measured net, meaning the actual installed length, but there is a snaking factor mentioned.
Clause 3.6e, you never pull a cable perfectly tight like a guitar string.
Why not?
Because buildings physically move. Pipes expand with heat. If the cable is pulled tight, it will snap under tension. It needs a little slack, a little snake in the tray.
So the contractor has to estimate that slack.
Yes. The client measures the distance on the drawing. They say point A to point B is exactly 100 meters. The contractor knows they will actually buy and install 102 meters to account for the snaking. Their price per meter needs to be slightly higher to cover that invisible extra length.
And then there is glanding and terminating.
A cable is completely useless unless it connects to something. Glanding is securing the cable entry into a junction box so it is waterproof. Terminating is stripping the wires and physically connecting them to the terminals.
Clause 3.6-H makes it clear this is a separate cost from the cable itself.
Usually, yes. But here's where it gets tedious. It includes marking the tails.
Marking the tails, what does that mean?
Imagine a thick control cable. It might have 50 tiny copper wires inside it. You have to strip every single one, and you have to slide a little plastic number tag onto each one so the electrician knows exactly which wire does what.
That sounds incredibly tedious.
It takes hours. And if you don't do it, the control system doesn't work. The rate for terminating has to cover the guy standing there with a pair of tweezers putting the number 42 on a tiny wire.
The WBS codes here go deep, too. I saw codes distinguishing between a 3-core 2.5 millimeter cable versus a 12-core cable.
It matters massively. Terminating a 3-core cable takes 10 minutes. Terminating a 50-core cable takes half a day. You need a completely different rate for each, or you will lose a fortune on the complex ones.
So what does this all mean for us? We have looked at the pipes, the steel, the wires. We have seen the trap of the fully inclusive rate. But stepping back from the details.
Stepping back, you realize that the unit rate is way more than just a number on a spreadsheet. It is a fundamental risk management tool.
How so?
By defining fully inclusive so rigorously in these preambles, the client is transferring the risk of efficiency directly to the contractor. They are saying, I don't care how many times you have to retest the pipe, or how much slack you need in the cable, or how many broom heads you wear out cleaning up. I'm paying you X amount for the finished working product.
It really forces the contractor to be professional. They have to think about every single step, from the quarantine of materials when they first arrive to the final flow arrow sticker on a pipe before they even bid on the job.
Exactly. And honestly, without these preambles, a construction site would be a constant, never-ending argument. The contractor would say, hey, you didn't pay me for the scaffolding. And the client would say, well, you couldn't install the pipe without it, so it should be free.
It creates a shared reality between the person paying and the person building.
That is the perfect way to put it. A shared reality defined by WBS codes. It is rigid, it is strict, but it is the only way to build something worth $1 billion without the whole thing collapsing into a massive legal battle.
So, to wrap this up, the next time you drive past a new building, or a massive factory, or even look at the plumbing under your own sink, think about the millions of WBS codes hidden inside those walls.
Think about the fully inclusive rate. If a pipe leaks during testing, or a hole collapses while they are digging, remember that the cost of fixing it was theoretically decided months ago in a single line item on a PDF, just like the one we read today.
It really makes you want to look at the fine print in your own life. Think about the preambles of the contracts we sign every day. When you hire someone to fix your roof, is cleaning up the nails from the lawn included in the rate, or is that going to cost you extra? Something to explore the next time you sign on the dotted line.
Always check your preambles.
Always check the preambles. That is all for our deep dive into the financial DNA of construction. Thanks for listening, and we will catch you next time.
If you're interested in the templates, please visit our shop. The link is in the description.
Thanks for watching. Please subscribe and see next time.